estamos traduciendo. La idea es que ustedes interactúen también con él. Cualquier pregunta, él está puesto para responderla. What I said basically is that you can ask you any question anytime. So feel free to ask and he will answer. Okay, sorry.
Yeah, sure. I have a question. Did you say that, for example, for the count of something, it can be stored as a function and it automatically updates if we add other records in other places?
So the question was, if the count, you can have it as like a stored function. You can't really have stored functions. You can have stored JavaScript, which isn't that great, to be fair. People have tried to avoid that. And it's not recommended at all. But what you can do is like, you can listen to changes within the database, like a trigger, but you do it in your application. And then when certain events happen within your database, you can then go update a different record as well. So it's eventually consistent. It's very similar to using like message queues and things like that, but it's inside the database. You have like a stream. I've got an example of it later. I can show you. Another question?
Hello? Yes? Well, you showed us multiple tables related with indexing, like RDBMS, no?
Yep.
How do you manage them in Mongo?
So normally you try to avoid like splitting data out as much as possible. But if you have like, when you have like, for example, this one,
Yes.
and you want to join them two together, you can do lookups in the database, which aren't similar, well, which are similar to joins, but not as performant. So you can send a query and say, join these two collections based on these IDs. And that's not normally as performant because Mongo's built for kind of sharding horizontally. So that's one of the fundamental like problems with like SQL Server, for example, for like doing sharding across different nodes. So if you're joining loads and loads of collections together inside of a single query, the performance is going to really drop. So what you try to do is like embed the data as much as possible. So for example, that example, where the author has some data here with a name, and it's also spanned across there, you just copy it into this document, and then you keep that in sync, eventually consistent. Yeah. Yeah. I think she got a mic.
Well, my question is about in the past, as you know, maybe you have some experience in SQL Server.
Yeah.
In the past, for example, when we are using SQL Server, we can save some pictures inside of each table, right? So my question is, on MongoDB, we can use the same behavior, or for example, we can just put the path of the image from some repository.
Yeah, so you can store files like big blobs of data, like binary data inside Mongo. You can store them inside the document itself as binary data. But if you want it to be able to scale horizontally and be able to stream the stuff efficiently, you can use something called GridFS, which is like another layer on top of Mongo, which allows you to like shard out a single file into multiple locations. So it chunks it into parts, and then you can read like the third chunk to the fifth chunk and stuff like that. So if you was like kind of like sending that file somewhere else, you don't have to download the whole document. You could just stream parts of it as well. And that's also like horizontally scalable as well. Yeah.
One question is about how MongoDB manages the integrity of the data. It's different or similar to a relational database?
Is it what, sorry?
The repetitions are allowed or not?
Other what, sorry?
The repetitions of data are allowed or not?
Duplication. The duplication, yeah. So you end up with the duplicated data, yeah, normally, with the kind of inside the documents.
How manage the integrity of the data?
How do you manage like keeping
normal forms or different?
Yeah, so like for the companies that I've worked at, we've used like RabbitMQ and stuff like that to keep data in sync with each other. But you can also use the database itself to stream data and then update other things as well.
Okay, and some advantage of MongoDB over another database manager?
So Mongo is pretty much the same as like SQL Server with like its capabilities of like, it's just a general purpose database. But the difference is it's a document database and you can shard it horizontally as well. And things like replication and things like that, where for availability and redundancy are just built in by default as well.
For example, for a data of a blog is better.
For what, sorry?
Manage entries in a blog is better.
Yeah, I think for most of the stuff that I've worked at, every company I've worked at, it's been better using Mongo because it's been faster for us to develop stuff. And we just didn't need to care about a lot of the things like migrations and things like that. As compared to like SQL, we've had to have a lot of like overhead on kind of like management and things like that. And developers, because it's more developer focused, developers think more about actually what they're building. As like, I find like with SQL Server, for example, places where we've used SQL Server excessively, we've had like 10 DBAs, for example, just doing like performance optimization for tuning like queries and things. As like, if you're modeling things correctly in Mongo, you don't normally need that. You have the same thing with inside Mongo, so you have like execution plans and things like that as well. And the indexes work exactly the same as well, so they're all B-tree indexes. So everything's very similar, except for the modeling's quite different. And also it does scales horizontally by default. So compared to like SQL Server, you can't scale across multiple nodes. You have to also automatically manually kind of shard your data yourself, right? And well, you can partition the data using different data files on different disks, which makes it a bit faster. But compared to having different separate computational like power for individual nodes, and Mongo wins on that because it's just built for kind of horizontal scaling.
Okay, thanks.
Yeah. Cool. Okay. So that's pretty much like an overview of like kind of Mongo itself. And then I was going to go into like how you can use Mongo in .NET. So one of the ways you can do that is just by using the Entity Framework provider. So for Entity Framework 8, there's a Entity Framework Mongo provider, which is like a collaboration between Mongo and actually Microsoft, who built this. And just put your hand up if you've used Entity Framework. I'm assuming most people in the room. Yeah, that's cool. So Entity Framework is really good to use, to be fair. I find it like super helpful to get things out fast. So by default, it's just an object relational mapper, but technically that's to get rid of the idempotent mismatch between the database and your code. But with Mongo, you don't really kind of have that. So it kind of like, you're not really mapping loads of tables into your objects or creating table hierarchies and things like that. But one of the good things it can do is just do change tracking. So you can go fetch something out of your database, modify it, save it, and it'll just go write the queries for you to update the data. So that means you have like, you don't need any knowledge about how Mongo queries or Mongo updates work. Same as if you're using Entity Framework for SQL, I don't need to learn SQL to actually store my data. So that increases developer productivity. You can like put more people in your team who are straight out of university, who don't know anything about SQL. You can utilize things like link. Everybody knows link in C# these days. Might be a bad thing, I don't know. And also it has optimizations for like things like lazy loading, eager loading, and query caching as well. So if you're pulling a document down and then not fetching the next document, it can just do that for you, or you can go fetch everything down as well. So similar to if you're using EF and SQL. So that means we can just create our models like this. So you just create normal records in C# or classes if you want to. So this is an example of all these examples are to do with like insurance and insurance API. So this has a policy with a policy, an ID, a policy number, a policy holder, a premium, and some claims on that policy. So it could be a policy against your like car, for example, and you crash your car, and you might want to claim on it, or maybe a house insurance. And then we can also create a DB context exactly the same as a normal DB context within like EF SQL Server. We can create a DB set at the top with a property. And then the only difference is this bit, this should work, this bit down here, which is configuring our entity. So within inside the SQL provider, for example, you do .entity and then build a to table. With inside the Mongo provider, you just do to collection because it's a collection. So that's pretty much the only difference. And then also the entity builder also has extra properties for mapping to different names of properties. And these are pretty much, if you just do dot, you can see them. So you do the builder.property, you can do policy holder, and you can do dot has element name, and you can map it to a different name for the properties. That's exactly the same as the SQL one as well, which is has column, has element name. And then when you configure it, you just add it to your ISC container, the same as the EF SQL Server one. You just do in the options, you use Mongo instead, and you pass a Mongo client in it and the database name. And then Mongo client is just like this thing up here, where you can just create a new instance of that, of a client with a connection string, and that connection string up there is MongoDB : / is the connection string. And then it'll just connect to your Mongo database. And that means we can just use it exactly the same as like you'd use EF any other way with SQL. So you can go to the IOC container, go grab the DB context, go get the, go create a policy, add it to the policies collection, just called save. And this will also automatically create you a save command for Mongo and go send it there. And then it'll also store it and get the ID back as well. Similar to if you want to use like query that collection, you can just do policies.where the premium is greater than the 100, and then just to list async it. And that'll just get you the expensive policies. And that'll just go write you that query, a Mongo query, send it to the database, send it back, and just translate that back into an object. And then if you want to kind of modify the document as well, or a policy, you can go fetch the policy using, why is it that way? You can fetch the policy using link again. So you can just do where the policy ID is this. We can go grab the, create a new claim. So maybe it's they're claiming because of theft or something. That's down here. This clicker's not really working very well. Oh, it says low battery. That's probably why. And then you can add it to the claims collection and then do save as well. So that'll automatically give you a Mongo update query to go update that document. So that'll only update the claims field as well. So it's not going to modify the whole thing and blob over it. It'll modify the single claim. And this is not working completely now. Yeah. So the, yeah, I could do that. You could, it's this was, oh, it's dying. Right, that could be useful if we charge it for a bit. Is this on? I think this one over there.
Oh.
It's a plug over there.
Oh, it's okay. That's fine.
Okay.
It's just for that. So that can charge for it. So one of the other things, so that's pretty much how you use it with the EF. But the problem with using EF, similar to using SQL, and why people start using things like Dapper, is because you can't like utilize everything what the database provides you. So for like Mongo, there's lots of other things what you can do which are outside of link, for example. So link allows you to like project things, do like where queries, group bys. But in Mongo, there's like text-based queries. There's also other queries where you can say where a certain field exists, because you can have fields which exist and don't exist. You can check the types of the fields. There's lots of different extra things we can do. And because you got that abstraction from NT framework and link, it means you can't do certain things with the database, which is exactly the same as like the SQL provider, for example. And that's why people go to using like using Dapper, for example, and just writing raw SQL in your code. And the things like also like performance as well. So if you're trying to performance tune a certain query or only fetch certain things back and make it do exactly what you want it to do, then you can start using like the Mongo driver. So this is more of a raw way to kind of use Mongo. So the EF provider has only been released about a month, I think it is, and it was in preview for about 3 months before that. And before that, everybody used to use the Mongo driver directly. So there's a lot of similarities to it. So we can create a model exactly the same as before. This is also a record. One of the differences is like you can this deserialization and serialization of objects within inside the Mongo driver is a bit more kind of tunable. So if you want things to serialize and deserialize in certain ways, you have more power over that. So I think that the previous model had didn't have a primary constructor for all the properties because EF doesn't like that. But the Mongo driver actually allows that completely fine. And you can also have immutable data structures as well. And EF doesn't allow mutable data structures. And these are applied using conventions as well. So this is like an example of how you could change your, this changes your everything into camel case. So all your properties are going to be in camel case instead of Pascal case. And also you can change it saying like you want enums to be represented as strings in your database, even though that makes it less performance. I probably wouldn't do that. And then you can add them to like a convention registry, and you give it an expression to say like at the bottom, you can see like where it says where the full name starts with demo2. So you can basically apply that convention depend on different types what you're applying it to. Cheers. And then there's a convention policy across your whole application where you can also map like certain classes and records. And you use this bcin class map to do that. By default, everything just gets auto-mapped to their conventions, so you don't really need to do this. But if you want to kind of like tune things and tweak things to make it like do what you want it to do, you can register a class map, passing the type as a generic, and then you can do auto-map, which applies all the conventions. And then you can then map properties and say like policyholder is then mapped to holder. So the policyholder property will get mapped to just holder in your database. And similar to the bottom one where the claim has an amount, we can then change the serializer to be a decimal serializer to make it so it generates as bcin decimals instead. So then we can do like range-based queries instead. By default, it stores it as strings because of older versions of Mongo didn't have decimals in the database. So we didn't lose precision, we had to store them as strings. But now we can store them all as decimals, so you can do queries a bit better. And then to kind of like do the ISC registration, you normally just plumb in the Mongo client into your ISC container. So you do add singleton. The Mongo client is similar to the SQL client. It deals with all the connection pooling. And then you can then register an iMongo database by just doing the get database on a client. And then the same thing for if you want the collection, you do the get collection, you pass in the type. And you can actually register multiple collections. So a collection can have multiple different types inside of it. And then you can register that. And then when we want to kind of use that, it's very similar to EF, except for it doesn't have a save at the end of it, because everything happens when you tell it to happen. So we can go get the iMongo client of policy. We can go create a policy, and then we can go call insert one async and pass in a policy to it. And then to find things, we can pass an expression to a find. So all the methods which are on a collection are all pretty much the commands which you use in Mongo. So these map more directly to the actual syntax if you were writing it yourself by hand. And these allow you to actually kind of have a more type-safe way of kind of using Mongo in C#. So you can go find the policy by its ID, and that'll give you a policy back. But you can also use these things down here, which are builders. And these allow, so this is kind of like link, where you pass in an expression. But with inside a filter, like on the filter builders, you have things like EQ, which is equals. So you pass in the property expression and then the value, and that give you that filter back. But that means you can actually do a lot more complex queries, as I said before. Like instead of like link, which is constraining us, we can also do like a filter, which is saying like where the premium is equal to 1,000, and then any claim inside that has also an amount which is greater than 1,000. So you can start doing like queries based on like how your data is structured instead, which is a lot harder to do in link. And then you can also do things like text-based queries. So you can do a filter.text, which will give you a text-based query, and you can change that to be case insensitive and change the locale as well to it. So I'll search for crash inside of the whole policy document based on a text-based query. So things like crashes, crashed, will also get picked up. And then you can also filter based on like things existing. So there's loads of different other commands what you can do for querying the documents. Yeah. And then the most powerful thing inside of Mongo is actually the aggregation query. So this is kind of like link. Every single stage gets applied individually to a bunch of documents. So that means you have like a pipeline, a data processing pipeline. And in C# you can just call aggregate, and it has like a fluent syntax to it. So then you can call like match. So you can say whether premium is greater than 1,000. You want to group by the policyholder, and for that policyholder, you want to get all their accounts and policies within that company. And then you want to match where the policy counts over 5, and then just project to the policy holder. So that'll get you all the premiums for a policy where you've got over 5 policies for them. Yeah. And then updating a document is very similar. So you can go, we can go create a claim. We can do an update. So this is actually telling it to go push an item into a collection. So this is where it's a bit more powerful as well. When you do updates, you can actually specify exactly what it's doing. So this is saying like this claim selection, I want to push this claim inside of it. And then you can then do an update one, which applies it to one document based on its policy ID matching, and you can just pass that update in as well. And then you can also do the update with the filtering the same as before with the actual filter builders if you need to specify exact things as well. Thanks. Deleting this exactly the same. You just pass a find object into the delete one async. And yeah. And then the last thing is pretty much transactions. So Mongo does have transactions out the box as well. You need in a replica set. So you need at least like 2 data-bearing nodes, I think it is. And it's very similar to like every other transactional system. You create a session to start off with. You start the transaction. You do a bunch of operations. So every single operation in Mongo that updates and finds and things also taking a session. And if you don't pass a session, it implicitly creates you a session at that time. So we can pass in our current session with the transaction started. It'll go send that to the database. And then it won't apply it all until we do a commit transaction async at the bottom of it as well. And then you can also roll that back as well. Yeah. So I've got a bit of a demo to kind of show of these things. So the first one is, so everything here is using the minimal APIs and .NET. Can everybody see the code? Okay, really, like, maybe if I change this to, so bad? Just squint. So the first like demo, the demo one is just using NT framework. So this has got this is just an API, which is using EF for Mongo. So this goes and creates this DB context, which you've seen before. This has got like, it just mapped to a collection of policies. If we sorry, I can't hold the microphone in time. So as I said, when you map the properties, you have a bunch of extra things as well. So you can do different conventions, add fields. You can do transformations, the same as the normal EF as well. And you can do has element name. So that goes and creates a DB context in our IOC container. And then we can build our application. And then we've got a bunch of endpoints for it. So we've got one which maps everything for policies, because we're talking about policies here. We map in a post, so just on the root, which takes a policy document. We go with that policy document, what we've got, we just add a new ID to it. We put it into the policies collection, and then we just do save changes. And then we turn back the policy. The get just goes and gets all the policies, and also has an optional policy number inside of it. If we've got a policy number, we apply a bit of a link query to it, which goes and fetch that policy number. If not, we just go return everything, and then we just return that from the API. We've got a get endpoint, which takes the policy ID into it, and then we do a where the policy ID is that. And then if it's not there, we just go not found. If it is, we go okay. And then this is the kind of like where like EF kind of is less performant than say the Mongo driver directly. So if we was updating our policy with adding a claim to it, with inside of Entity Framework, we have to go fetch the policy itself. So that gives us policy based on its ID. If we don't have a policy, we want to turn not found from our API because the policy doesn't exist. And then we also want to then add the claim if it does exist, and then save the changes to the database, and then return the claim, what we just saved. So if we just go run this, we can see this just working. If I've got Mongo running, yeah, all good. So that should be running. So I've got a HP file here, so I can run some queries against the API. So if you go create a policy, so everything's a bit big on my screen. So if we do a post this endpoint of policies with a policy number, a policy holder, and a premium, this will send the request off, and we'll get a response here. So that's just saved into our database with no claims on it. We can take that policy ID as well, and we go down here, and we can filter based on that policy. So we can send that request off to our API, and that'll just go return the response here, which has only got one item in it. If we want to go create some more policies, and then go query it again, that'll still return a single one, but if we go remove our filter out of it, this thing here, this will return all our policies what we've created. And then the fun bit is, let me just copy this ID. So then if you want to go create a claim for that policy, you can pass the claim ID into here. And then this is going to just put a claim in here saying the water leak in the kitchen. What that means. We can call that, and then that'll go add a claim to our policy. And what we can do is just go look in, this is the Mongo shell. There's some IDs as well, UIs for Mongo as well, but we can go look at all the databases inside my Mongo collection. I can type. And it's got this new one, this new database called Insurance Demo 1. So if I go change that database, and then do show collections, and it's got a policy collection inside of it, so then we can just do db.policies.find, and this will find all our documents what have been saved in our database from that API. So this is the one which is just added the claim from it. So as you can see, I didn't create any like schema for my database. It automatically created my database and collection for me. I didn't need to do any of that kind of stuff. It just magically just worked as I expected to. That's using the entry framework. So the other API, which is this one, is using the Mongo driver directly. So I'll try to move this a bit. So this is exactly the same as before with all the endpoints. So this just does an insert one instead of using entity framework. So he just goes and grabs the iMongo collection, just does an insert one. This uses the aggregation pipeline instead of actually the EF link provider. So that just does a match if there's the certain policy number on it. Fetching the policy by its ID is just a find, which is this one. And then this is the more interesting one. So adding the claim to the collection, actual policy. So as we saw before, we had to go fetch the actual policy, modify the policy in memory, and then save the policy, the policy with the new claim on that policy. And if you use the Mongo driver directly, you don't have to do that. So what we can do is we can match based on its policy ID, and then we can also just say, go push that claim into the claims collection for that policy. And then when we get the result back, we're not even fetched the data from the database yet at all. We don't really care what data's there. And what we can say is, like, if you've matched any documents to apply this update to, then return OK. If we haven't, we just return not found because we know that document's not there. So we didn't need to fetch all that data to kind of put that into memory. So it makes it a lot more efficient. So there's one last thing on the Mongo stuff. And that's change streams. So as I said before, like, you end up with like a lot of duplicated data in your system because you don't normally normalize the data. You kind of just duplicate things and then keep them in sync eventually. So change streams allow you to like listen to changes in your database and then technically just build real-time applications towards it. So just any changes inside your database just kind of do something. Yes. So these change streams can be opened on like collections, the database, or a whole cluster. The events are read off a thing called an uplog. So this is like the change log for the database. An uplog is also used for keeping like replica sets in sync, so you don't end up with like data loss. So normally you run a 3-member replica set within Mongo, and it usually has like probably an hour or half an hour like data to sync between them replicas. And the change streams uses that under the hood to kind of do the changes, that push the changes to you. And this means you can also start change streams in the past. So if I want to say like, I want to listen to all the policies being created half an hour ago, I could send that query to the database and it'll go push me all the collections, all the documents which have been created half an hour ago to now, because it already knows about that. And also change streams can be resumed as well. So if you're listening to a stream of stuff coming from your database, you get a token which you can pass back to the database if your application crashes, or you might need to do a restart or deploy a new version of the application. Very, very similar to if you use things like Event Grid or Kafka. Yeah, thanks. So the operations you can listen to are documents being inserted, updated, deleted, things being invalidated, the database being dropped, collections being created, dropped, index being created and dropped, the collections being modified. So if you're changing things like the collation on the document on the collection, sorry, collections being renamed, and also things being sharded and changed, the shard key changed. So these are pretty simple to kind of do as well. So on the collection, you have a watch property, and that gives you a cursor, and that cursor you just keep enumerating forever. And there's a helpful method called for each async, which just gives you like a callback every single time that change happens. And you can also pass in, with the aggregation pipeline, you can also pass in an aggregation pipeline to apply to a change. So this allows it a bit more efficient for querying. So if you just do a watch on your database, you'll get single thing in the world that's coming straight into your application. And you probably want to only listen to certain things. So for example, this is just creating a pipeline, which is only going to match on operations which are in an insert. And then it's going to pass that to the watch, and then it's going to then just only give you inserts into your application, what's been changed. And then you can also specify things like the full document. So if you want the document, what it looks like, being passed to you as well, it'll go look that up for you. But there's different ways to do this. So there's an update lookup, which gives you the latest version of the document. So if the change happened half an hour ago, and you said, I want the full document of an update lookup, it gives you the document what it looks like now, which might be different from when it actually changed half an hour ago. So then I've got a little demo of this as well. So I'll just change this over. So this is just running the code exactly what you've seen on the slide. So this is just getting a database, getting the collection, building that the pipeline of an insert, and then watching it and fetching the full document out of it, and then just iterating over the cursor every single time you get a change, and then just writing out the policy number saying it's been created. So that's running there. The thing that's listening to the chain streams coming through. And then this API is also running. So if we, don't do that. So if we go back to this, and we send some changes through. So if we want to create some policies, we can run this, and it should go create some policies. Might be a bit slower because of the Wi-Fi. Come on. Oh, it blew up. It had a timeout. Oh, it was about this. Maybe that's not. This is connecting to like a cloud instance of Mongo, so it might not work very well. Let me just. Okay, that's not working. It's not connecting for some apparent reason. You just have to believe me that it works. So that should be an example of like kind of how like you can listen to changes in your database and keep other things in sync as well. And you can even like do things like if you got a policy which is like being accepted as a status, you can now send them an email, for example, and do things like that as well. Even though that might not be the best, like maybe if it's a small application, it's quite useful. Or if you just got it in a smaller bounded context, it can be quite useful before you go to things like messaging instead. So that's pretty much it for the Mongo talk I've got. So we went through some documents, how you model them, and different usages inside of .NET. So Mongo has loads of stuff on their site. They've got Mongo University, which is really, really useful. They've got pretty much every language what you can do, and then they have like things about being a DBA, performance tuning, and things like that as well. There's a thing called Mongo Playground, which is like a website where you can use to just like play around with like queries as well, which is quite useful. But yeah, that's pretty much it for that talk. Does anybody have any questions?
Questions?
Yeah.
Okay. Let's wait.
Thank you. My question is about, I saw part of your code in the demo one. You're using some kind of synchronization, using await. My question is is it possible to use some parallel for each when we try, for example, doing some upload several documents at the same time? Or have you ever used something like parallel for each?
Yeah, so you can send multiple
Yeah.
commands to the database at once. You're always going to be constrained by the connection pool. So it might be more efficient to just do a more of an aggregation query to go fetch all the things what you want to fetch in one query, because that's going to be a bit more efficient, and not use as many TCP connections, for example. The async and await stuff is really just for being non-IO blocking for things like when you build APIs and desktop apps and things like that. So then things are a bit more responsive. You're not wasting loads of threads just hanging around, really. Any more questions? Yeah.
What recommendation would you give to us in case of multi-tenant architectures?
Pardon?
What recommendation would you give us in case of multi-tenant architectures?
Oh, so normally I just the best thing to kind of create a horizontally scalable application is just a shard based on a tenant ID. But it depends on it. There's lots of different constraints. So most companies what I've worked at, even in financial companies, so I work in a finance company at the moment, we still have all our tenant data together, just stored in one database. And we just segregate it based on a tenant ID and just make sure we've got really good access controls to make sure tenants can't access other tenants' data. If you're creating a multi-tenant application, I just create some kind of unique tenant ID to them and just add it to every single document, and then making sure you can't query across documents if they haven't got the same tenant ID, for example. Yeah.
¿Alguien más tiene una pregunta? Okay.
Hello. Hello. Besides entity framework, what other package or maybe ways to get information from MongoDB can you share with us?
Sorry, I can't.
Okay. Besides entity framework, which other ways we have to connect or do a query with a MongoDB database?
Yeah, so these are two examples in .NET you can use. You can use the EF provider, or you can use the Mongo driver directly, which is more of a raw way to use Mongo. You can connect to using the shell, like I did a second ago, which gives you just a shell to kind of query it, like you can query SQL as well. And then they've also got if you used to things like SQL Management Studio and things like that, Rider and Data Grip, which are by JetBrains, support like a Mongo ID kind of thing as well. Then there's also Mongo supplies a thing called Compass as well, which is a lightweight kind of tool to query the database as well ad hocly. And there's also some paid for products as well. I think it's called Robo 3T, I think it is, which is a paid for product, which has more features as well. So you can query it that way as well.
Okay, and is there something like Dapper that we have for SQL?
Yeah, so the Mongo driver directly is very similar to Dapper.
Okay.
So you can just write raw BSON documents inside of C#, but you probably would never do that unless they haven't got. So the only time you normally end up writing raw BSON documents if it's queries is if the driver hasn't supported the latest version of the database engine yet. And the database engine has got more commands what it can do, and the driver hasn't got them yet. And then you can just write pretty much raw BSON documents in the middle of your code. But the driver team in Mongo are always up to date constantly all the time, so they're never really behind.
Okay, thank you.
Yeah.
Hello. As MongoDB is built for the cloud, and there are different cloud providers, we can deploy it. I know there is also MongoDB Atlas, that it's a database service. Would you recommend it to test it or against the other cloud providers?
Yeah, so that just depends on your company, to be fair. Like, if you've got enough infrastructure team to deploy your own Mongo cluster, and they can also deal with like the backups and also of like disk failures and the node failures and things like that, and keep replication like in sync and stuff, then that's a more cost-effective way of kind of like managing your cluster. But if you're like a team of like, I don't know, 50 people, and you don't have that dedicated resource, it's much better to just use things like Atlas, because you can just deploy it there. And to be fair, the cost efficiency of Atlas compared to like, if you use like AWS have a version of their Mongo instance, which is called AWS DocumentDB. And that's actually more expensive than using Atlas. And that's because they just, it's pretty much how much their VMs cost, plus a bit extra. But because Mongo uses, Atlas uses AWS under the hood as well, and they have reserved instances, they get a much cheaper cost because they've already got that dedicated resource to them. So that means there's cost saving for you in the first place. But as like a developer, like Atlas is so much easier to kind of work with, and then also you get the portal to be able to query like the collections and things like that as well. And it also comes with like a graphing tool as well, so you can graph your like data and things like that as well.
Okay, thank you.
Yeah. I think Atlas comes with like a free, per project, it's like free 500 meg database with a maximum of 100 concurrent connections. So it's pretty decent for actually doing stuff.
Hi, I have two questions. How do you think are the key advantages of MongoDB against, let's say, DynamoDB or Cosmos DB in core flavor? And also, a friend of mine that it's DBA says that DBAs don't like document database because document database are more developer focused. So there is no kind of space for them to administrate like they used to have in Oracle SQL Server. So because most of the things that we need to do in order to do tasks requires to use a high-level program like C# or Java, but DBAs don't like to program.
Yeah, totally. So the first question about like what's the benefits? So Mongo, like as you said, like DynamoDB is horizontally scalable as well, same as like table storage and in Azure. But you have to kind of specify like your sharding key or partition keys up front before actually querying them. And then partition keys as well are only single value. So you have a like in DynamoDB, you have a what is it? Your partition key and your row key, I think it is, or what it's called. In Mongo, you don't just have two values to kind of play around with. You can create a sharded index across like 10 fields if you wanted to, or you could create it across one, depending on like kind of your data really. So the capabilities for sharding are a lot more configurable as well. And you can also do things like shard based on location as well. So maybe I wanted like shard data which is stored by people in Peru. I want to just keep on the shards in Peru, and the ones which are in England, I want to keep on the shards in England. So I have data locality, and you can do that with sharding inside of Mongo as well. So you might not use sharding just for kind of horizontally scaling, but you can use it for data locality as well, which makes it a lot more efficient. Also, things like developer productivity, like using Mongo with C# is a lot more productive than trying to use it with like using DynamoDB inside of C#, because you have to know all the queries and expressions yourself. Everything for Mongo just comes up in IntelliSense when you click dot. And yeah, so they're pretty much the main things. And then for the thing for the kind of like DBAs, I've worked with quite a lot of DBAs, and they usually have a lot more DBAs on SQL Server projects than Mongo ones. But I have actually worked with like some DBAs who actually have totally happily kind of used Mongo. And you get the same things out of Mongo as SQL Server. So you still get like, you can do profiling on your database. So you can enable a profile and say, go log me all the queries and the execution plans over this time period when they exceed over a second, for example. And then you can go look at all them kind of query plans, see what indexes they're using, like then try find a better kind of like index which covers most satisfying queries, and then you can apply that as well. So the same concept applies for both database technologies. It's just like, I feel like you're correct, like people who are from SQL Server or Postgres and stuff like that kind of rebel against like kind of document databases, and I think that's just because they just don't want to learn something new, to be fair. But a lot of the time, like I have also worked with other DBAs who have happily kind of like jumped onto Mongo and just started like kind of poking around and seeing what's slow and things like that as well. Because they're very, very similar. That's the thing.
¿Alguien más?
I know that we can use MongoDB on Docker, right? And so we can use inside of a container or something like that. In your experience, do you think it's this is the future, using MongoDB over inside of a container, or it's a better approach to use on a server installing MongoDB?
So testing it locally and running things locally, I'd just use Docker. Just because Docker's super easy to spin everything up, all it depends on your application. If I was going to the cloud and like kind of deploy my application, I'd definitely probably use Atlas, which is their like SaaS offering of like the database. And that's because then you don't have to manage anything, right? They just manage your data. You pay for like compute, memory, and storage, and they just deal with everything for you. And then you just get a portal. You get all your access control kind of stuff for your business in there. You can like connect it to like LDAP or any other kind of provider for your like security. So if you want only certain developers to only have read access to the data, and other lead engineers to have write access, you can set all that kind of stuff up. You don't need that overhead of actually manage anything. If you run it all in Docker, then you've got to then create like 3 Docker container instances across different availability zones, and then connect them all together as a replica set and manage all that stuff for yourself, which is a lot more overhead. And as a developer, you probably don't want to do that. If you've got an ops team, then it kind of makes sense. But if you're just trying to get a product out to market, it kind of doesn't make sense.
Yeah, okay. Thank you.
Does MongoDB has language for definition and manipulation data or not? And what is the process for design a MongoDB database in?
What do you mean? Sorry.
In some words.
It says, can you repeat that? Sorry.
Can
you repeat? Sorry.
Well, my question is about saying the relational database that manage language for definition and manipulation data, no? And MongoDB has language like that or not?
Yeah. So Mongo has its own like query language and stuff like that. But I'll show you. So you don't have to kind of use where are we going? So this is like the shell to Mongo, and this is the query is what you send. So if you do a find, that just finds out. But if you want to find based on like the policy number, you can. This is pretty much like if you're writing SQL. So if you think about that as like that's a BSON document, what it'll get converted into, and then that'll get executed on the server. So we can run that, and then that'll just do a find and find the policy number of a certain type. So everything passes back. So it's not like the BSON objects itself are like the SQL. So it goes and sends them and translates them back and then passes them back to you. Is that what you mean?
And what is the process for design a MongoDB database, or is it simpler?
What to design a Mongo database?
For design a MongoDB database.
Yeah. So normally you design your
simpler or is?
Yeah. So as a developer, I find like working with Mongo a lot simpler because I create things based on aggregate roots. So most of the stuff what we build are based on like using domain-driven design principles, where you have an aggregate root which is like maybe your policy document, and then things off that which have operations on it are in your code, which do operations maybe like add a claim, and that has validation for adding a claim and all that kind of stuff. And so when we kind of like the structures in our code are exactly the same as a database. So then there's no kind of disparity between the two. As if I was like storing that in SQL, I'd end up with like a bunch of tables which have like no concept of any of the domain at all, right? There'd just be a bunch of tables flattened. Yeah, cool.
¿Alguien más? ¿O estamos? Okay. So let's take a break around 5 or 10 minutes. Yeah, we have pizza, so feel free to take it.
Duplication, redundancy, and then you hybrid model. So there is a
Yeah, I think the thing is like with most things, like you need to forget about all the concepts.
yeah, right.
And then students will be
And you need to relearn. There is a different design process. You have to normalize.
Yes, but the thing is like that's more, even though that's what we do, that's more normal. So like we had like when I was in really we had a big ones and zero like experience about how databases. But then we get it longer and then it's more normal. It's still like as they are all in one because things are related. Right? Like your policy has claims on it, so you just got to you don't go create a policy table and create a claims table and group it together. And if they got like a policy table, some more data and put a new table, like that's very unnormal. Like,
You didn't learn before.
Yeah. If you didn't learn at university,
But for people that came from
Yeah.
you have to say, no, you have to keep they normalize. We will talk about the DBA.
Yes. So, and here's what you did in my last place. We had longer there. And one of them was same time was jumped on it. It's like, oh yeah, I'm going to look at that. And he even would start writing on Terraform scripts to actually do all the flows for the methods, doing everything, right? But he was like really wanting to learn and passionate about stuff. And then there was other DBAs in the company. He was literally just like, if it's not SQL Server, if it's anything to do like Windows machine or something, I'm not just it's like this. I think like Terraform scripts and not just so they were very like
And I think it depends like what DBAs it's like. It's like there is some like old school DBAs who don't know what they do. They just want the same thing on the done for the last 10 years. And then there's other ones where quite like more modern who are happy to write like DevOps scripts for like Terraform or Ruby or.
I was wondering how you usually manage the index definition.
Hola, para todos los que quieran ir a los servicios, están por allá. Así que... eso. Aviso de servicio público, se acabó la pizza, solo hay gaseosa.
There is like you know that SQL ecosystem is really there is a lot of tools ready to handle this problem.
So there's a bunch of like new
Okay. So it is cool.
and yeah, there's a .NET so you
Okay, and this kind of big scale application, usually we will have a separate team that handle this kind of operations for the development.
any account of with any point of sale device or expenses or so we have all that data and we use like your block storage and I've built your block storage for run for 200,000 pounds, which is ridiculous. So block storage is cheap. Yeah. So you use it like massive. Yeah, so we use that platform. We also use that platform. But yeah, usually the teams just manage the data themselves.
Okay. Do you know that MongoDB is not quite popular in the .NET ecosystem compared to, for example, the Node.js or the JavaScript ecosystem?
Yeah, that's true. Well, it's more popular.
Yeah, for sure. It's been with us for ages. It's more solid approach to use a
It's been in about 75% of people about that.
Oh, that's interesting. I was wondering what are the, let's say, challenges that you face if you move from the relational world to this document?
I think it's what you said before. I'm sure people love it. Because they try to love that it's the same and then the comments just
Yeah, because you have like relationship and relational also, which is
yeah, you can also sort of go queries and say like, Joey is flexible together. Yeah, voice is not efficient. And then when you start horizontally saying, so you get into like, so I can figure out what time you have 16 sharp and 16 sharp. If you said like join and functions, it just it's kind of like we have here. We have to say some queries for all 16 shards. Then you find the collections which like match that. So then it goes like exponentially.
Do you usually use a different database or something for reads? Because in many of these web applications, users love to search in kind of different ways, in sort, in Ruby.
And you can tell what I was saying.
Oh.
So you can have it say, second bits of road, you always do that. And then you just go through they might be depending on the system, depending on like, you can tweak it to like, you want to put the system, there might be more, they might
I don't know if you use Mongo or still use Mongo.
Empezamos en 3 minutos, así que pueden ir tomando asientos si ya terminaron de consumir su pizza.
It's written. Yeah, cool. Yeah, so the next talk is actually on testing. So I've been pretty much really passionate about testing for like probably the last 10 years. And when I started testing stuff about 10 years ago, I didn't do it how I do it today. It's been like a learning curve which goes up and down, where I've been burning myself and then just finding new and better ways to do things. And yeah, I think that's pretty much everybody's like learning path for kind of like how you do testing within applications. You learn things, you learn it's not actually not that great a way of doing stuff, and then you go back to the drawing board and then apply different kind of principles. And I've only done this talk. Don't need that again. I've only done this talk like once before, and this was at a conference in Hull in England, actually. Yeah. So the idea is we'll go through like how we can get testing confidence, the different types of testing, about mocking, because I know a lot of people like mocking, how we can layer up our tests so we have more reuse of code, different things like production dependencies, and also different technology choices which allow testing. So this is an interesting slide. So you should be like, why should I trust you? So you probably shouldn't, because I just do what I want to do. And to be fair, like in my day job, I just pretty much like try to do the best I can do at high quality, so we don't have like outages for customers. And to be fair, we've released like the team where I work in, we've released like code to production, which is broken straight away, and then we'd have to refix it and deploy like a fix because we didn't write enough tests, so I didn't understand like things in enough detail, what would happen in different scenarios. So this is not that, you can't really be like, your tests aren't going to make you perfect, but they're going to give you enough confidence to like things should work as you expect them to. And I've also taken loads of bad choices and failed many times as well. Like when I started like doing a lot of like TD code, I started doing katas, so where you kind of do things over and over and again over like simple problems, and doing testing on top of that, which is completely different from testing your business application as well. So then you realize like the differences in things, you fail at something, and then you learn a better way of doing it as well. So yeah, and also like one of the main things as well, I've talked to lots of people at conferences and things like that about how other people have been doing them and alter my own personal ways of doing things based on that as well. And these are just like, obviously the learning experiences. So if you do it a totally different way and it works for you, that's perfectly fine. If not, you might want to take some stuff on board. It's also fine. But yeah, as I said, like tests are all about gaining confidence. And like before I wrote tests, I used to think my code was perfect, to be fair. Like I used to ship things out in production, they worked perfectly fine. I had no clue if I wrote like bugs in my code and things weren't correct. And then I started writing loads of tests around everything I did, and then realized how atrocious developer I am. And all to the point, like even like a couple of days ago, we've got like some really terrible deployment process with our company for kind of, we have to edit some text files with different numbers. And I always do that completely wrong, and that should just be automated. So things which are easy to, things which are like kind of like easy to fail at, you'll just fail, right? So writing some tests around things gives you a bit of confidence. Even if you write a few, it'll actually make it, things improve. It also helps your peers as well understand what your code's doing, because I think most people have opened a code base and gone like, what the hell is this supposed to do? And then you read the code and you're like, is it supposed to do that? And you've got no idea if it's supposed to do that or if it's intentional, not intentional. And it's just really, really confusing. And if you've got a nice set of test suite, which actually then proves that that weird bit of code is supposed to exist, then it makes everybody else's life a lot easier as well. There's loads of different like words for testing as well, which really annoys me. So that's one thing where everybody's terrible at in software development is naming things, and different testing terms is awful. So in like Google, they call their tests like high, medium, big, medium, small, which doesn't really mean anything. Other people call things integration tests, acceptance testing, unit testing, functional testing, exploit testing. Like there's loads of like terms, and nobody really defines these terms, and it's quite confusing. And when people join other companies, and you join another company, they also use a different set of terminology as well. So one thing what like I worked out at my previous company, it was just trying to like unify how we talked about tests in our business, because everybody just like used like functional integration and different terms into trying to like differently depending on what project there was on. So we tried to kind of like unify all that kind of stuff, which made it a lot easier to work with. So these are usually the three kind of like testing strategies, I'd say, that I use. So I usually create a lot of functional tests, and on Microsoft documentation, they call these integration tests. But everybody who I've actually met as a developer also calls them functional tests, which is weird. So don't just trust Microsoft. And then usually we have like a really small amount of unit tests around kind of very pinpointed things which you want to test in isolation. And then we also then have a bit more of like end-to-end tests across the whole system for things like when we deploy our application, we want to just sweep across the application to make sure everything is working. And I'll kind of go into kind of these in a second. But like different projects have different kind of like ways of testing, and you might have less functional tests and more unit tests, depending on how like complex your system is, etc. So within like kind of like a domain, so this is also an insurance API, we have like a service which is like our insurance API. And inside that insurance API, technically we just have lots of functions, right? Everything is built up as a function. And then functions are sometimes talking to some database, obviously going to be Mongo now. And then they also talk to like some third-party APIs as well. And then normally you have some kind of connection into your API, some HTTP requests, some gets, and some posts. And then also you might have some messages coming in from some message broker like Azure Service Bus or RabbitMQ. And then also, it's not just built up of one service. You've got many, many services in your business. So we might also have a claim service for when they're dealing with claims and kind of refunding people. And they also have their own gets, posts, messages, and also their own database in isolation as well. And when we talk about functional testing, this boundary here is where we're testing our service functionally. So that's all the behaviors which this service is actually going to behave. And if you wanted to test a claim service, that would be also in isolation. And then if you want to test a unit of work, it could be across a single function. So normally maybe a pure function. So everything entering that function and exiting that function can test in isolation. Or it actually might be a bunch of functions, right? So a unit test doesn't have to be pinpointed to a single function. It might be just a single behavior, which is composed of 5 functions, for example. And then the end-to-end tests kind of probably cover the whole system just to make sure that everything is like working as expected. And we'll cover like why that is later. So a functional test for me personally, every time you commit some code to your build server, maybe using GitHub or Azure DevOps or the Atlassian projects, every time you commit your code, it's going to run the functional test to prove that it's going to work functionally as you expect it to. That means you get instant feedback that if you've broken anything. We also test all our APIs from our entry points, well, services and APIs from our entry points. So anything that's coming into our services is going to come in either using a HTTP request or a message. So we can just like go send that HTTP request or post that message onto a queue and get to read off the queue. The functional test is usually around a single bounded context. So for this example, it's just the insurance API. It might be across the claims API, claims service, which is in the background as well. And then we also try to use like as much like real services as possible. So if you're using SQL Server, we'll spin up SQL Server in a Docker container locally. If we're using Mongo, we'll do the same thing. Same thing for Redis and Azure storage. We'll just kind of like, we won't try to mock out anything which this service kind of owns. And then things like external dependencies, like if it talks to the claim service, we'll just mock that because that's not part of our domain. And also third-party APIs will also mock that as well. And then for like the services which are owned by that boundary, so the boundary-owned services, we use it like the company where I work at the moment. We use Docker Compose. So we pretty much have a Docker Compose file in the root of our like service to say like all its dependencies. So if it's using like RabbitMQ and Mongo, we'll just have that in the Docker Compose file. So then it's easy to spin everything up either locally on the build server. There's also other tools called like things like test containers, which people seem to love. I played around with it, but I'm not really. I'd rather just use Docker Compose. And there's also now .NET Aspire as well. So if you've used that, that's really useful. You can also tell it to provision all your dependencies in Azure as well. So you don't need to actually run. So Aspire either wraps up Docker locally instead of using Docker Compose, or you can tell it to provision your resources in the cloud as well, which is quite useful. Which also makes all these really easy to like run locally or on the build server. And you should treat everything as disposable. So all your data which you're using for your test, just throw it away. You can even use like the temp file system mounts as well within Docker, which actually makes your databases run super fast because they just get stored all in memory. And then when it terminates the actual instance, it just all dies. So this is what Docker Compose looks like, if anybody's not seen it before. So you pretty much just declare like the services and the root. And then, okay.
Kevin, sorry to interrupt.
Yep.
Could you go back to the previous slide? I have a question about, so about the boundary on services. So that term boundary, it resonates on me like the term on domain-driven design, like bounded context. Is that related to it?
Yes, yeah. So more of your, so if you're using like domain-driven design, then your bounded context is pretty much the boundary what you're going to be testing in isolation, right? So that's going to be a single part of your business. Maybe it's the sales or the claims service because they have a claims team, or maybe it's the API because they deal with like quotes, for example. So then, that they kind of link to kind of like that bounded context. Yeah. So that's a compose, which is usually how I spin like my services up. And then on top of that, if you're using it, building an API, And so it's similar if you're building like just a background service as well. You can use the web application factory, which is part of like .NET now, which is super useful. So this is like a web application factory is just a class inside of like the testing framework for ASP.NET Core. And the idea is it closely resembles just using like Kestrel or Hostnut on IIS. And that means you can just interact with the server in memory as it is, all set up as it would be in production. So you can test it in isolation. And it also means you can also swap out the dead dependencies as well for your tests. And we'll see that later. But out of the box, it just gives you like you create an instance of it and it gives you a HP client. So then you can poke at your application using HP requests. And this was kind of what it looks like. So normally you can just create an instance of it. So you can just create an instance of web application factory, like the generic type. But most of the time you want to inherit from it and have a baseline configuration from it. So for example, this is just like inheriting it from it, and we're giving it a name of Insurance API Application Factory. And then we've got this configure web host, which reconfigures the web host for it. And then we're just reconfiguring some like IOC container services. It's not working again. So then we can reconfigure it. That's not working again. How annoying. But it has loads of other methods as well. So it has a bunch of things to like what assemblies it's going to scan, how you can configure the HP client. So maybe you want to send a certain header every single time to your application. You can configure it in there. So every single time you create a HP client, you can add the header to it. It's got stuff for creating the host builder, so you can reconfigure that. Yeah, thanks. And then to use our application, web application factory, we can just go create an instance of it. We can go create a client from it. And then we can also then just like call post async, which is a method on the HP client, pass it the URL what we want to post, and then just pass it the content. And then we just interact with it exactly the same as if we're just calling an API itself. One second, my throat's getting sore. So we've got like our base configuration for that, our web application factory, and then we can reconfigure it at runtime for each test as well. So maybe we've got some app settings which you want to toggle on and off because you use feature toggling, for example. We can then use this with a web application host builder. It gives you a delegate back of the builder, and then you can reconfigure it in line. So we can go change the settings within our app settings. So you can set like food to bar. And then we can also add an extra like dependency in our IOC container, so you can add my service to there as well. And then things like authentication, you can create your own authentication handler and just like push that into your application as well, just for your tests. And then you can just go to like add services and then add the authentication handler. So if you got like, if you don't care about, you've got authentication on your application, you don't care about like kind of like how it behaves, you can just just mock out the authentication handler and say like, all requests are kind of authenticated, and here's a bunch of claims where I expect. Or you can then add certain claims in depending on your tests as well. And then normally you want to kind of like encapsulate as much like logic as possible in your code, so you're not like copy and pasting code everywhere. And these are things called harnesses. Well, I usually call them harnesses. People sometimes call them fixtures. So yeah, I call them kind of harnesses, and they're kind of a way to kind of encapsulate some kind of logic around your tests. So this is an example of a harness. So this is just encapsulating the web application factory, and we're just adding some methods on there now to kind of like build up like some domain knowledge about how we test our application. So for example, this has got a post quote, which just takes a JSON node into it. It there goes and creates a HP client, goes and posts the data, gets content, and returns the status code in the content, because that's all I want for my tests. And I just, from my test point of view, I just want to call this method called post quote. I don't really care what it does under the hood. So it's kind of encapsulating all the kind of like things from my API. They also kind of like, we can start using the harness for enabling certain things as well. So because we can reconfigure our web application factory, we can reconfigure it here using the with web host builder. And this is changes like maybe you got a feature flag, and this feature flag is to turn internal credit score calculation on. We can just flip that toggle and then swap out the factory. So now we've got like a method what says enable internal credit card calculation feature, and that encapsulates that logic for that. We don't have it spread around our code, and it's just part of our harness. Similar if you want to kind of start disabling like a message bus or like removing some of the services out of our ISO container. So we do this at our current company. We use Rebus as an abstraction layer for RabbitMQ. And for a lot of the tests, we don't really care about RabbitMQ, connect to RabbitMQ every single time. So it puts some overheads and makes it more memory intensive. So we just remove that service. So it's not actually consuming like messages. So we just disable like message buses. So you can add like another method on there to just reconfigure services and give it some meaningful name. And then we can also build up these harnesses with more harnesses as well, because if not, we'd end up with like a massive harness of like 20,000 lines of code. So maybe operations on what we want to get out of Mongo, for example, or maybe we've got like some bureau like kind of API, what we want to kind of control. We can start like layering these harnesses up and adding them to like a root harness. So this could be like a root harness with a Mongo harness inside it and a bureau harness inside that as well. And then this is like the bureau harness, which you can't really see that well. But the idea is like, again, we're encapsulating things which are like kind of meaningful for the domain. So at the top of it, it has like good bureau data. So that's data about the person, which is good, and bad bureau data. So we're kind of like naming these things like as a well-known thing. And then inside it, we've got some methods which actually says add good bureau data, add bad bureau data. And that means like people reading things we're actually calling this code actually know exactly what it's doing. We're not just dealing with primitives. So that's pretty much how we can encapsulate lots of stuff in our code to kind of make things a lot easier to kind of write lots of tests and not have loads of duplication within our code. And then the next thing is like mocking. So I've been on loads of projects where like mock and substitute, fake it easy, and all the other testing like mocking libraries are really, really overused. And I did this personally like about 8 years ago as well. And I think it's just a kind of bit of a learning curve for testing, where you kind of like, you write loads of tests around your code and start mocking all your dependencies for all your classes. And then when you try to go add an extra feature, you go into the code, you change the code, or try to write a new test, and you can't write the new test because all the tests are so tightly coupled to your implementation because of all the mocks. You end up just deleting all the tests and then just adding the code and then trying to write more tests and just missing half the coverage what was there before. So normally I try to like avoid using mocking as much as possible, especially if you're using like mock and substitute, because they tightly couple your code quite a lot. And if you need to kind of have some mocks, maybe for some third-party APIs what you're calling or services what you're calling, then just hand-roll your own mocks. So this is a kind of example. So I've got like an iBureau client because this is from like maybe a NuGet package. It has a thing called get bureau async, which you pass in the first and last name, and that's one that the methods on the interface. But also I can also within my my mock class, my mock bureau client, I can add my own methods which actually give meaning. So I can add my add bureau data method, which goes and adds some data to this class, which then the mock can use. And comparing that with like things like mock, where you use a .setup.returns and you end up duplicating that code everywhere, this makes it much more simpler and a lot easier to maintain and read going forward. And then the setup data, usually like a lot of the time now I'm using like records for things. So we usually create a class which has a bunch of like known kind of values. So this has got like a quote resource representations. So this is like a representation of what we're going to post to our API. And inside here, we've got like a static member, which is a successful quote. And this is just literally what our successful quote looks like to us in our domain. So all our tests are going to use this like successful quote and modify it to do different scenarios. So the main thing we want is a successful quote, but maybe we want to change things on it to make bad requests and things not work as expected. So for this example, like we've got a successful quote, and we can use the with keyword because we're using a record, and just to change the from date to be yesterday. So we can't, this would be created as an invalid quote because the quote can't start from yesterday, for example. And then the last, one of the last things is deal with JSON data. Like a lot of the time when people use a web application factory, they'll just use the null default serializers within inside of .NET and just post the actual object, create the object, post it, and use the same object which you use in your API as in your tests. And the problem with that is like, this has been like me and a lot of people I know, you've gone in and like maybe you change like the name field to be first name on your model for your resource for your API. Your tests then still pass perfectly fine, and then you go deploy it to production, and then all your customers start complaining because the field name has changed, and you've just broken your API contract. So a way to do this is just to kind of hand roll all your own JSON, what's going into your API. So everything is very explicit for what you're doing, and it is a lot of overhead to kind of like write loads and loads of JSON and build that up. And you can use things like JSON node and JSON documents to do this in a typed way inside of C#. You're not just writing a big blob of string, for example. And if you're using things like Copilot, it'll just happily write it for you anyway. So you're actually probably not going to be writing any extra code if you pay for Copilot or if your company pays for it. So this is kind of like how the JSON node, how I build the request for the API, for example. I'd taken the actual type which I'm playing around with to create, which is the quote, and then I'll actually just decompose that into a JSON object. So I'll take the individual properties and then put them into the property I expect. And now, like, if I go change our maybe our first name here to just name, then our API, our test will start blowing up on our API because it's actually still sending first name. And before we even go to production, we'll know we've broken our API contract straight away. Similar to like the request going into the API, everything coming out of it as well. JSON document is like the immutable version of JSON object. So we can just go traverse the JSON document for the properties of it and just assert them are the correct ones, what we expect as well. So the similar to before, instead of actually just comparing deserialize it into an object, which is what our API is using, we're actually looking down at all the properties, what we expect, so we know we're not breaking our contracts. And then the test isolation is another thing. So we want to keep our tests as isolated as possible from each other so we can run as many concurrently as possible. And one of the ways to do that is just to use a tenant ID. So most systems these days are multi-tenanted, or multi-tenanted in a way that maybe your customers are in isolation, maybe not business to business, but maybe business to customer, and the customer is in isolation. You can create a new customer every single time, or you can create a new kind of tenant every single time. And if you can't do that, you can just create a new database every single time. So if you're using a Mongo, for example, it's pretty easy to just use a GUID for your database name, and every single test run, you just create a new database. And that's pretty efficient. So overall, like we want to kind of create expressive tests which kind of describe what our application is doing. So all our tests, what we kind of write, kind of look like this. So you want them to be like expressive as possible. So the start of it is just like pretty much act, arrange, and insert, really, or given, when, then. So at the start of it, we go grab a successful quote from our quote representations. From that, we go add our bad bureau data for that quote. So we go to our harness, go to bureau, go to say add bad bureau data. We then go post our quote to our API, and then we expect the status pair to be 200 OK, and then we also expect the quote to be what returned to be correct and in a declined state as well. So from because we've encapsulated all our stuff into harnesses and use classes to encapsulate how we do our assertions and things, then we can start reusing that across multiple things. So we can use this same code and just change this for add a successful bureau data and expect it to be accepted, for example. And it'd be exactly the same. And then another thing is like libraries and technologies make it like really easy for you to kind of, well, either really easy for you to write tests or really hard for you to write tests. So as I said, we use like Rebus for a lot of stuff at our company, and that is really hard to kind of test. Hard to test. As like other like kind of libraries, such as this testing framework for your API is built by ASP.NET Core, and it's really flexible and easy to configure. Mass Transit also has a very similar thing, which is like another message bus abstraction. But there's lots of like tools out there. So when you're picking libraries for your application, don't just think about like the functionality, what they provide, also the testability of them as well. Because if you want to test your system thoroughly, picking a library which isn't very testable, you just end up writing like 10 times as much code to try to make it more testable and wrapping things up than actually writing tests. And the other thing is like when you pick technologies to use, such as databases and things like that, try to pick ones which are also easy to start up and you can run on your build server. Nothing's more worse than kind of like having a maybe like a technology what you're using which you can't run with your tests. So one of the like examples of that has been like Azure Service Bus, for example. There's like a GitHub thread like a mile long of people complaining about that you can't run Azure Service Bus locally. The same as Cosmos DB as well. There's like a Cosmos DB like emulator in Docker now, but it crashes like 9 out of 10 times when you run it. So yeah, picking the right technologies allow you to like write tests more efficiently. So the last bit is like the demo of kind of like what we've kind of talked about. So where's that come? So this is so this is usually how I organize my tests to start off with. So we've got the functional tests up here. We have well, to start off with, we'll go look at our tests. So within our feature folder of quotes, we've got a post-quote test. And then, it's far too big now. And then inside of here, we have just all our tests, which are kind of API for our posting quotes to do. So we have like, should return 400 for a bag request when the data's in the past, which we saw on the slides. So we go get a successful quote, we change our from date to be in the past, we post it, and we just expect it to be a status code of bad request. We also have things like when the duration's out of range, so we can't have a insurance quote for more than a year. We just modify the duration from a successful one, and then we just go build it, and then just expect it to be a bad request as well. And then for things like if it's a successful but declined request from the bureau data, we can just check that that's an okay request because the actual payload, what we send to the API is correct. And then when we assert it, we can just check it's in a decline result. We can also check like things like got no matching bureau data. So if you got no matching bureau data, it just checks it inside of Mongo that you've actually not got anything saved for it. So it goes and does the post, goes and gets the ID back from the API, and then just goes and get the document out to Mongo for that quote, and then asserts that using this Beeson quote assertions. And this is similar to like the JSON, to be fair. So like in Mongo, everything's stored at Beeson, and because we want to prove that the schema isn't changing inside our database when we save things, we can just like go look at every single individual field as like a very rudimentary way. So yeah, we end up like with loads and loads of tests, and all our tests are really, really simple, pretty much say what they're doing out of the box.
Kevin,
yeah,
I've got a question. You scroll up a little bit, please. Yeah, like this on line 91.
Yeah.
Well, I work with some old folks that continue to work with code, all like classic ASP and all that stuff. And they always tell me when they say, when they see that name of the fact, in this case, like should return 200, blah, 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 blah. and they tell me, why do you make your name so long? And what would you tell them? What do you tell to those folks about choosing those kind of long but descriptive names?
Well, you want to make them as descriptive as possible for like the next person. So I could just write these as like works, and that's fine for me to prove my code works. But then when my fellow colleague comes along and like is trying to understand what this code does, and maybe has some like code in there which has some weird permutation of like what they don't understand, they can then like go to the test to prove that actually was that was like a meaningful change what they did, and there's actually tests to back that up. And then normally if your test says like kind of what it says on the tin, then it kind of like it's just more descriptive, and it helps people down the line.
Yeah, so descriptive over short keywords.
Yeah.
Okay, that's perfect. Guys, if you have any,
I think the thing is with like the naming conventions of tests as well, like I flip between like lots of different ways of doing it, to be fair, because I sometimes do should returns blah 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 blah, or I do like given when then, it usually depends on like what I'm working on, right? So normally like these time of tests is because I'm just hitting an API endpoint. I'm just like, this should return this when in this condition, right? But normally if it's like more of like an end-to-end acceptance test or something, then it's normally like a given when then, like more like a Gherkin kind of style one, but not using spec flow because nobody likes that.
Right. Por si acaso, cualquier pregunta que tengan, en cualquier momento, anímense a hacerla, ¿sí? Así es.
Cool. Yeah, so then for like, let's have a look. So yeah, so then we can run all these and they should all just pass. Just to prove our API works, yeah, so everything is happily in green. So they're functional tests. The next one is like unit tests, and this is kind of very controversial because people like always say like unit tests should be wrapped around a single class, which I kind of disagree with loads. And that's usually because that's pushed by Microsoft. And if you look at any other kind of like ecosystem, if you go into like Ruby or Python and any other language, they do it completely different. They think it's like a unit test is pretty much how Ken Beck says it was. And that's like more of a unit of work around, or a behavior around of something. So for us, this might be like a single function, what we're testing, or it might be multiple functions, what we're testing. But as to like the functional tests, we're going to run them every single time on the build server. We're only going to really write them for more complex logic because we've got these high-level functional tests already testing everything downstream. So maybe it's like something really detailed what you want testing because it's got lots of permutations out of it. Then for unit tests is a good use of that. And yeah, also if there's too many permutations from a higher level to keep hitting your API all the time and saving loads of data and things like that, then you might want to write unit tests. And usually my unit tests are pure functions as well now. So before I used to like mock things out of classes and all the dependencies of a class out. And now I've realized like it's much more effective to just write unit tests around pure functions. So the parameters getting passed into the functions, expect this result back out. A lot more kind of easy to reason about, and you can also change that code a lot more efficiently as well. So you can change it in as that code without breaking all your test suite as well. So I've got a short demo of that as well. So inside of our, I'm not sure you code yet, but inside of our insurance API, so this is using minimal APIs, and we have a map quote endpoint. So this is just a post endpoint on a quote, and you can't see half the stuff. So this is just mapping a post endpoint on the quotes. It takes in a resource representation of a quote, the time provider, a bureau client as if it's talking to an API, and a Mongo collection as well. And all it does is create this quote using today, the applicant, the from, the duration, the quote, and pass out the quote and pass out the error. So this is usually more like a domain object to have everything encapsulated in here. So when you try to like create this quote, we have a bunch of validation around this stuff saying like, if it's before today, we want to fail it. If the duration is not in this given time frame, then we create the quote if it's okay, and then just return it. And then we're going to go get the bureau data from this API, which we're also mocking out. We go fetch that bureau data, and on that bureau data, we then, after getting the bureau data, then we can go calculate their quotation. So that means we have enough data to actually do the quote for them. And then inside of here, we've got like a scorecard calculator. So this is a way for us to like either accept or decline that they're going to be accepted for the quote for this insurance. And the score calculator is just a static class with a calculate method on it, which just passes all the information what it needs into it. So it passes in today, the applicant data, and the scorecard, the credit score, sorry. And then this does all the work for kind of calculating if it's accepted and declined. So this checks their age. So if they're under 18, they'll get declined. If they've got a credit score of under 500, they'll get declined. If they're not a nationality of UK, they'll get referred. Sorry, Peru. Everything else to get approved straight away. So in our functional tests, we never really covered all them permutations of saying like, what happens if they're 10 years old? What happens if they're like 80-year-old for our quote? We didn't care. The reason why we didn't care is because we only cared about certain scenarios within inside of our functional tests. So when we did our quotes, we've got a test over a referred quote. So every single like output to that scorecard, we have a functional test for. So the outputs are accepted, referred, and declined. So we've got a functional test which has a successful quote which is accepted. We've got a referred quote, which is just where that nationality is the US. And then we've got also a decline quote where the applicant's date of birth is like in the not as old enough anyway. So we've got like them 3 tests inside our test suite for functional testing. But inside our like unit testing, to prove all them permutations of the scorecard calculation, we then have all them in a unit test wrapped around that pure function. So then we got all these tests instead. So similar to before, we have something what denotes what today is, something what denotes like what an approved client is, and something what denotes an approved credit score is. And then from that, we can just say, should be approved. If we pass in today, the approved applicant and the approved credit score, and it should get an approved out of it. And then we should say, then the next test is like, we should decline an underage applicant. We've got the year, the month, the day. So then we can create the date of birth, change the approved applicant to the date of birth, which is like underage, and then pass that to the credit score calculator, and then they get declined. So then we've got pretty much the same kind of concept of like how we build up our data, what we're using for our tests. So we've got something which is actually the thing which is going to be approved or the positive case, and then we can modify that positive case. So that's for all the different kinds of like scenarios are there. So back to here. So the last thing is end-to-end testing. So we have a bunch of like end-to-end tests in our company, and these don't get run on the build server. Well, they do get run on the build server, but after we merge merge the code into the main or master branch, and then we deploy to an environment. And once we deploy to an environment, then we run a bunch of like more happy path tests across the whole system to make sure everything's working. And we call these end-to-end tests. And these normally are cover a lot of behaviors of a lot of different services under the hood. So it might be like 6 teams worth of services which you're testing as like a whole. It ends up being multiple API calls or clicking screens and using like Playwright or Cypress to kind of do that. And yeah, they're always kind of usually happy path scenarios across the system. And these are really good for like testing like infrastructure as well. So maybe we're changing from using like within Azure, for example, we're changing from using app service to using container apps instead. And we want to swap between them two services. We can change our infrastructure code, swap between them two services, run our test to prove that our applications still are working together. And then that works okay. And we can't kind of run them tests on the build server at build time when we commit our code because they're outside the realms of that. So that's usually what we use end-to-end testing for. I don't have any kind of examples of that. That's fine. But that's pretty much the whole of the kind of like testing stuff, really. So to start off with, it was all about confidence. So test about confidence. You're never going to be completely perfect, but talking about like kind of the tests what you're writing, working together, pairing with people, mob programming is actually quite good to kind of like get a better test suite of around your application. We talked about functional testing, which is normally like the main thing which we kind of strive for. So try to cover your like either your service or your kind of API with functional tests. We talked about how we can encapsulate like logic and make it so our tests are really like slimmed down and actually just say what they're doing. And then we talked about unit tests are really good for detail testing at a lower level. And then end-to-end testing at a really high level, but more for kind of happy paths. And that's pretty much it. Then we got questions.
Hi. In the previous slide, you mentioned to avoid using mocking, msubstitute, mock-u, and so on. So what I'm not sure if you are saying that avoid using in functional test or avoid it completely, because if you are running unit tests, you need certain kind of mocking because you cannot access, by like example, data.
Yeah, so for your functional tests, I'd only mock the boundaries of it, right? So if you was calling up to a third-party API, for example, so in this example here, where are we? So in this API here, we go off to another API called Bureau Client. And this Bureau Client is technically just like another third-party API, right? So in England, we have a bunch of data bureaus like Equifax, and they store lots of information about people for their credit score and credit rating and things like that. And that'll be like a third-party API call, and we'd mock that out, right? So within our tests inside our application factory, we'd literally just create a mock Bureau client, which is this, which we're just hand rolling our own mocked version of it. We're not using like mock or end substitute. And then we just map it to the iBureau client. But then that means we can just wrap things up to be a bit more usable for a testing perspective, because we can then start saying like, oh, good bureau looks like this, bad bureau looks like this other thing. So one's got a better credit score than the other. And then we can also wrap things up, so add bureau data to that client. So then we can just resolve that service and just add stuff to it. So then it's all kind of encapsulated in that. And if you want to debug this as well, you can just like put like breakpoints in the middle of it and see what state it is as well. As if you're using like mock or end substitute, it's a lot harder to do that. So there's still going to be like mocking for certain things in your code base, but I try to just avoid kind of mocking your own things. So things which you own, you shouldn't need to really mock because that's part of your application. Hmm? Yeah. Yeah, so we create our own mocks without any mocking library, yeah. Then that's so we can encapsulate things a lot easier and give meaning to things. And then for what you said before, like more unit test stuff, you don't really need to mock things out if you create pure functions. So if you get the dependencies what you need beforehand. So for example, in this scenario, this goes and gets the bureau data after you do the request in, and then it calls calculate quote on the quote, which then calls like scorecard calculate, and this is a pure function, right? So this technically, the scorecard calculator could have a dependence on the iBureau client, right? And you didn't have to kind of go fetch the data first and then pass it in. But if you had that, then you'd have to mock out the bureau client inside the calculator to then seed the data every single time. But because you're fetching it out of it, the logic what you're testing is the logic what you're testing doesn't care about the iBureau client, for example. It just cares about the input to that function to give that given output. So if you start like creating things as pure functions and testing the pure functions in isolation instead, because they're going to be the more complicated logic, then you're not going to need to mock as much as well.
¿Hay alguna otra pregunta para Kevin? For instance, I have one. Kevin, you mentioned about the pure functions, and that's a concept about functional programming, right? So I don't know, I have a question for all the members here. If you are all familiar with pure functions, how are they implemented?
Yeah, sure. Pure function is a function that base the output of the return on the input. So if you always call with the same input, you always get the same result, basically.
Yeah.
Basically that.
Yeah, so then if you have dependencies inside your class, then it never is a pure function, because then dependencies could change the response, the output response of the function. Yeah.
Even the system data you...
Yeah. Even the system date, right, for example. If you took the dependency, if you just took that in as a dependency instead of passing it in, then that could be a change, right? I'm going to take a photo as well, people.
Hi, Kevin. A general question. You said that you, 10 years ago, you started doing TD. You mean test-driven development?
Yeah.
And when did
Maybe
you...
over 10 years.
Okay. But when did you realize that you, that you had the skill to start doing that? Because I'm new to the TD, and I realized that I need to learn a lot about testing before being able to do a test and then develop this feature and so on. So maybe how much practice or how much projects?
Yeah, so I started doing testing by attending some user groups like this. And they had sessions where it was hands-on sessions of workshops where people grouped together in like 4 or 5 people and just did like more mob programming. So we had katas, what we worked on. So do you know what a kata is? Do you know what a kata is? So a kata is like a you get a spec for what your application should do, and then you have to like implement that spec. And you do it in like a way which is, you keep doing it over and over and over again, the same one, and trying to work out better ways of doing it. And we used to do them quite a lot together as like a group of people, like a meetup like this. And the one person used to write a failing test, and then they used to pass the keyboard to the next person. They have to make the test pass. And then they write a failing test, and then pass it to the next person, and then keep doing that. And I've worked like that at companies as well. So companies that I've worked at before where we've done mob programming, that's pretty much what we did all day long. Like one person wrote a failing test, you pass it to the next person, they make it pass, write a failing test, pass it to the next person. And you have conversations while doing that. And that's pretty much how I learned TD to start off with. But it was a very rudimentary way of like kind of how you did the implementation and do the testing, because a lot of the TDs are like, there's one which is like the shopping basket kata, which is about like kind of, if you go to the supermarket and you buy an apple, it's like $10. And then if you buy 3 apples, it might be $25. So you might get an offer for like 3 apples compared to just buying 1. So there's like rules what you kind of have to apply, and you can apply them using like TDD. And there's like, so that's a lot different from building an API for a big company. Because it's very like just really small part of the system, right? So that's where like kind of like you start like you learn the TD stuff, and then you're like, oh, how do I even apply this to like the real world? And then you start writing like tests around like individual bits of the code, which ends up making you mock load the things. So you write the tests around single classes, and you start mocking all the dependencies of that class, and then you realize that's also a terrible way to do it. And then you first focus on a bit further out of doing it, and then you're writing it against the APIs and like functional testing, for example. And then I think it's more like an evolution. You just kind of like get there eventually. And to be fair, like in 2 years' time, I probably won't be doing exactly the same thing. I'll probably have changed like how I'm doing things, because like within the last 2 years, I've changed quite a lot of like how I structure my tests and stuff like that as well. So I think it's just more of an evolution of kind of like what works as well. And it also depends on what application you're working on. So I used to work on like Amazon style lockers for business to business. And we used to have mobile phone devices which connect to Bluetooth. And we had to kind of mock all that stuff out. So we had like a Raspberry Pi, which kind of like pretended to be like a locker. So then our phone app could communicate to it, and we could have like certain things which actually give certain responses. And that was also different again. So it also depends on the business and what you're building. But I think it's just like practice, like most things. Like you just have to keep like trying, and then you'll get there eventually. Ken Beck's book is a really good book to read. It's about I think Ken Beck does a book on TDD. It's quite an old book, and it's all in Java. But it's if you squint, it looks like C#. Yeah, I'd read that. That's really good. And there's also a talk by a guy called Ian Cooper as well on YouTube, and it's the title talk is "Where Did TDD Go Wrong?" And if you watch that, that's really good. It's like an hour long. That's really good.
That's quite an interesting strategy to get your way on TDD. Could you write down what that strategy you said on your laptop? Maybe I didn't pick it up, the term.
Yeah.
What's the word?
There's yeah, so I think they're the really main points. Like,
Thank you.
is that what you meant? Sorry. Yeah, cool.
Take a picture. ¿Alguien más tiene una pregunta?
So we use code coverage at work to kind of like, if we've accidentally kind of done something stupid, right? So it's really good. So code coverage like per commit, like on a pull request, is kind of pointless to me, because I can pretty much get 100% code coverage by writing some reflection code, right? Like it does not test the behavior of my application. As like where it's really useful is if like your trends of your like code coverage and it's going down over time, you probably got something wrong, or it's just like gone from like 99% to like 20. You probably got something really badly wrong or something. So it's quite good for that. And if you got good reviews of your pull requests and stuff like that, they usually pick up on like, if you're skim reading, you should be able to skim read all your tests and know the behavior of your application quite fast. That's how I find. But yeah, code coverage, like kind of, yeah, as like a single metric, yeah, isn't great. Like most metrics, like people game them, right? So like I've worked at companies where we have metrics around like kind of how long a ticket takes to get progressed. And like you can just game it, right? So once you know the metric what you're trying to game, you just game the metric, right?
¿Alguien más se anima a hacer una pregunta? ¿O están? Okay.
Hello. Maybe some developers have some knowledge regarding some unit testing framework like NUnit or XUnit. And you, in your presentation, something regarding Web App Factory. How can you compare or
so like all the testing frameworks are pretty much the same. So XUnit, NUnit, Fixie, what else is there? MS Test, if anybody uses that. Like they're all identical, right? The reason why everybody uses XUnit now is because when like .NET Core became a thing, XUnit was the first one to like port it to .NET Core. It took NUnit forever to port all their stuff, and that's because their assertion framework was so big, and it took them forever to port over. So everybody started using XUnit because it was already ported over to .NET Core the fastest, and that included Microsoft, right? Everybody in Microsoft, you also use it pretty much. All people in Microsoft for all their projects also use XUnit, right? Mm-hmm. Nobody uses MS Test. And the reason why nobody uses MS Test is because MS Test used to get released per the release cycle of Visual Studio. So instead of just being a NuGet package what you download, like everything else, you used to get it with Visual Studio. And when they released TPL, the Task Power library for .NET, using async and await, the MS Test didn't support it for like a year. And every other test framework supported out of the box in like about a month. So MS Test got like binned at the side, and XUnit became the first, even though NUnit was the first originally. And then these other ones like Fixie and stuff like that, were trying to be a bit smart. Who were like, Fixie's like, you can configure it to look like any testing framework or your own testing framework. So if you like customization, that's quite useful. But yeah, there's not much to compare between them all. And then the like Web Application Factory is just like another layer on top of ASP.NET Core, which is just a testing framework for them.
Okay, thank you.
¿Alguien más?
And how interact programming language with MongoDB? Because I say MongoDB has its own code in C++ language. O sea, maybe its code is inserted in the code of the programming language, or how it interacts, or is through its driver.
Yeah, but that's like everything. Like most things aren't written in the same language, right? Like that's one of the bad points. Like people chose like RavenDB, for example. RavenDB is written in .NET, and the performance of it is terrible. And there wasn't the fault of the person who wrote it originally. It's because it was written in like .NET framework, not .NET Core, and it's been ported across and it's fast now. But people picked that database because they thought like, oh, it's written in .NET. I'm writing a .NET application. I need a database which is a .NET database, which is just silly because like SQL Server is written in C, right, as well. Like most databases are written in C or C++. Or these also, what's the other one? Rust, yeah, Rust as well. So a lot like the IBM database, they're porting things over to Rust as well, because it's a lot easier to kind of manage.
Okay. And in which businesses you say MongoDB is ideal for applying?
Everyone.
Which type of business?
It's just the thing is it's a multi-purpose database like SQL Server or Postgres. So you can do the same thing across all of them. You just end up, you just have different caveats.
Yeah, okay.
So it's like most things in software development. There's no ideal scenario. You just like kind of outweighing different caveats. So like Mongo is pretty good for like scalability, with sharding, developer productivity, that kind of thing. But also, like if you're using like SQL Server, there's a lot more people with like skills in SQL Server. If you want to do, I don't know, performance optimizations and things like that as well, there's less people doing that. And it's the same things like if you pick a language, right? Like in the UK, in certain cities, you can tell the difference in languages, right? So like when I went to university in Sheffield, it was very much like C# and Ruby. And Ruby's disappeared, now it's Go, all right? And like in York, where I live now, there's a lot of C#, Swift, and C++. And that's because there's lots of games developers there writing C++ and C#, the game developers using Unity. And like the different places have like different languages as well. So it's not like picking a language for your business isn't always just about like the features of the language. It's also about the resources and stuff as well. Like loads of people say F# amazing, but I probably never start a project in F# because there's nobody to hire. So it's kind of a bit pointless.
Which is the market share into between the development language, which is the market share of MongoDB into the database.
Compared to all databases, it's the highest used document database, and I think it's like the 5th highest database overall, because like things like SQL Server, Postgres, MySQL come right at the top, right? MySQL comes right at the top because of WordPress to start off with. And then I think it's like about 4th or 5th. So it's literally nearly like touching well, it's quite a bit further down, but it's the highest one. It's the highest document database, and it's nearly catching up with the like relational databases.
Okay, and the last question, how is the demand for MongoDB specialists?
How much?
How much the demand?
I don't know. It depends what country you're in.
MongoDB specialists, how is the demand?
I have no idea how much they cost.
Is high demand?
I don't think it's that high demand, no. But there is like MongoDBAs and stuff like that, like job adverts like in England, what you see. Or the thing is like most of the time, like with any building or any application or using any database, it's usually the developers focused all the time. And like a lot of things, like everywhere I've worked, developers are responsible for everything, right? So we write the code, we write all the code to deploy the infrastructure on the cloud, we write all the stuff to do with the databases and do performance tuning, we write all the tests, we do everything. We're not expected to like just do one thing, we're expected to do everything. So then like we don't have a DBA at our company to manage our performance of our data. If there's performance problems, it's the developer's responsibility and they have to deal with it. And it's also the developer's responsibility to put metrics in place around like open telemetry, for example, to make sure we capture them performance problems so then we can fix them because it's our responsibility, right? So the thing is, if you start segregating teams out and saying like, these are the developers who just write the code and these are the DBAs who deal with the database, then they're going to have to kind of sift around in the database to figure out like what the performance problems are. The developers don't care, so they're not logging metrics about things. As if they do start caring, then they have the right information, the right tools to build the right things so they can actually monitor and actually produce better quality software. Yeah.
¿Nadie más? Ahora sí.
Cool. Can I take a photo of everybody in the background?
Okay.
Excellent.
Smile, smile.
Everybody can wave.
Smile, guys.
There we go. Perfect. Perfecto.
Thank you, Kevin.
Thank you. Thank you for having me, to be fair.